Hey, welcome to week 8. I have an activity I want to try to do with you here that if we were in the classroom, we would all be up and engaged and walking and moving and feeling what I want you to feel in this thing. I don't mean feel like emotions, but feel the mathematics. But online, here we are. So I'm going to do my best to replicate this on this lesson I would do in the classroom, do it online. It has to do with this. Angles, which you've been studying from Module 7, and polygons that you were studying definitions of earlier. So, just as a quick reminder here, here is a three-sided polygon called a triangle. And in this triangle, there are 3 angles. Those are interior angles, you see, because also there are exterior angles. You get the point. But I want you to focus on the interior angles of this triangle, not the exterior ones. And the question I want you to think about is, suppose we were to measure this angle and this angle and this angle, and then sum them up. What would the sum of the angles sum up to? The measures of those angles. Now, also, as you do this, I want you to, if we were in the classroom, this is the part you would feel, because you would actually move and feel the angle. So instead, I'm going to try to show it to you in this PowerPoint, but the idea is this. An angle has to do with how much rotation has occurred. You know, even back when we were measuring circumference of a circle, imagine a full circle. We want to know the circumference of that circle. That's the first thing, the attribute of measurement. What do you want to measure? Well, we want to measure the circumference of the circle. Second, find something else that has the attribute of length, radius. Compare multiplicatively. How many radius lengths? Well, we use that same notion when we measured angles. So here's an angle. So what are we measuring when we measure an angle? Well, what we're measuring is the portion of the circle that's kind of cut off by that angle. That's a terrible circle, but I hope you get the point. So we're going to measure that. Now, but that was created because of some rotation. And it didn't matter how big or how small we made the angle, because even if we measured this, it appears to be bigger. But we're measuring this relative to this radius, where here we would measure this relative to this radius. And so it was all proportional. Proportionality comes in too. So it wouldn't matter because of the proportional relationship. But the idea here is when we measure an angle, we're measuring an amount of turn. Now, you guys are probably pretty familiar with the amount of turn in terms of degrees. So if you go 90 degrees, a nice right angle, a quarter of a turn. If you go a quarter of a circle, you would rotate 90 degrees. Let me show you 90 degrees. And if you did another quarter, if you went to there, that would be 180 degrees. And if you went to here, that would be 270 degrees. And if you went all the way around once, that would be a full 360. So keep that in mind. We have 90 is a quarter of a turn. 180 is a half a turn. 270 would be 3/4 of a turn. And then 360 would be the full turn. So keep that in mind as we do this, because what we're about to do is take you through the sides of a triangle. The sides of a polygon. We're going to start with the triangle. And we're going to work our way up. We're going to do a quadrilateral. We're going to do a pentagon. We're going to do a hexagon. We're going to do a heptagon. We're going to do an octagon. We're going to do, I don't think I had a nonagon. I think we have a decagon. And what we're going to look at is, if we were to determine how much rotation, how much angle measure inside of all those interior angles, and sum them up, what would we get? All right, let me stop talking and show you. So I have here some feet to try to show you that rotation. Can you imagine? I'm going to leave this one here so you get to see the starting position. So here the feet are pointing along that first segment. All right, so the feet walk, ding, 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 And when the feet get to this first interior angle here, I want the feet to rotate that interior angle, not the exterior. I don't want to go, you can't see if I point at that screen. I don't want to go around that way. I want to go around this way. So I'm going to rotate that way. Now, if we were in the classroom, you'd actually be walking this. We use string, and we make a triangle. We get 3 people to be the corners of the triangle, and a 4th person would actually be the one walking. And when they got to that first angle, they would have to rotate the amount of turn to represent that first interior angle. And notice now they would walk backwards towards the next angle. Now, likewise, when we get here, we want them to rotate that next angle. We don't want them to go around that way. That would be the exterior angle. We want them to go through that interior angle, so we rotate. And then we walk down the path towards that last angle. Now remember, I hadn't yet measured that first angle. The first set of feet just walk straight. So now we want to get to that last angle, and I want to rotate through that first angle. Not this way, that would be exterior. We want to stay interior. And so if I rotate interior, that last angle, notice what happens. The feet are now facing exactly opposite where they were. So here's what happened. I won't move the feet this time, but the feet rotated around so they're facing opposite how they started. So if you rotate so that you are opposite where you started, how many degrees did you rotate? That would be 180 degrees. Yeah, if you sum up the angles, the interior angles of a triangle, we measure all 3 angles and add them together, you're always going to get 180 degrees in a triangle. And so back to this, I want to just record that. You should record it too. Write this down. So a 3-sided polygon, aka a triangle, if we sum up the measures, we get 180 degrees. Awesome. All right, let's just do one more before I kind of let you loose here a little bit on this. So the first set of feet on this rectangle, it's also a trapezoid. It's a special case of a trapezoid called a rectangle. On this rectangle, we're going to start the feet this way, and every time we get to a corner, we're going to rotate. Now, you can probably guess what's going to happen here because 90 degrees, 90 degrees, 90 degrees, 90 degrees. 4 90s, that's 360. Seems like as we go from a 3-sided triangle to a 4-sided quadrilateral rectangle in this case, it seems like the interior angles should add up to 360. Let's check it by walking. So far, no rotation has happened. We walk to that first angle and we rotate through that interior angle. Notice the rotation needs to be this way. Now I don't want to go around the exterior. So once we get to that first angle, we want to rotate that interior angle 90 degrees. Walk, 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 walk. Rotate through. Notice now we are facing opposite how we started. So there's 180, 90, 90, 180. Yeah, of course. We rotate in this angle. We want to rotate through that angle. Gotta get me out of the way. Rotate through that angle. And then walk, 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 walk. When we get to this last one, we want to make sure we rotate through that last angle. And notice we're in the same direction. So what happened? If you watch this carefully, we started here. We got to that first angle. We got to that next angle. And we got to that last angle. I think I missed one there. But we rotated all the way around a full 360. So it's true. Now the next one we'll show you is not just a nice friendly rectangle, but a general quadrilateral. But yeah, it looks like these add up to 360. Now let me pause there. Please don't Google it. Don't just guess. Don't just continue, but actually think for a minute. As we went from 3 to 4 sides, the sum of the angles went from 180 to 360. What do you think's going to happen on 5 or 6 or 7, right? A pentagon, a hexagon, a heptagon, an octagon, a decagon. What do you think's going to happen? Go on to the next video after you've done some thinking and find out.